Hello everyone. The architecture of fluids, mechanics of viscosity, Stokes law and surface tension based on principles of mechanical properties of fluids. Flow is a system of sliding layers, laminar flow model. Here moving plate, this is fixed plate, physical velocity, here it is 0. And you see this is the velocity gradient. Viscosity is internal friction. Just as solids resist movement across a surface, fluid layers resist movement against one another, while oil flows with layers sliding easily. Honey resists due to interlocking layers. Quantifying resistance, the coefficient of viscosity eta. Mechanism, a fluid layer pulls the one below it forward while the one below drags it backward. This creates shear strain. Definition, the coefficient of viscosity eta is the ratio of shearing stress to strain rate. SI unit is Pauli or Pascal second. F equal to eta A V by L, force required to maintain motion. Eta, coefficient of viscosity, A, area of the fluid layer, and V by L equal to strain rate, velocity by distance between the plates. Variable friction, temperature and composition. Here you see the temperature dynamics. Liquids, viscosity decreases with temperature. Here you can see the liquid decreases with temperature in this way. Liquid decreases with temperature. In this way it is decreasing. And gas increases with temperature. Viscosity increases with the temperature in case of gas. It is increasing, right? Biological insight, blood versus water. Water at 20 degrees centigrade viscosity is 1. Blood at 37 degrees centigrade is 2.7. Blood relative to water 0 to 37 degrees centigrade is constant. Now we get another important thing, this one, that is physics of falling viscous drag, Stokes law. You see Stokes law equal to gravity equal to buoyancy plus viscous drag. When a body moves through a fluid, it drags the fluid layers in contact with it. The fluid exerts a retarding force. The Stokes law formula of F equal to 6 pi eta A P. Eta is the viscosity of fluid, at A equal to radius of sphere and velocity of object. Achieving equilibrium, terminal velocity. As an object accelerates, drag increases. Eventually, the upward force is drag plus buoyancy equals the downward force gravity. The acceleration stops and the object reaches terminal velocity. The balance 6 pi eta A Vt plus buoyancy is equal to gravity. Therefore, we are getting 6 pi eta A Vt equal to 4 by 3 pi A cube rho minus sigma into g. So, the final formula we are getting is Vt equal to 2a square rho minus sigma into g by 9 eta. Here rho is the density of a sphere and sigma is the density of fluid. Sigma is the density of the fluid, rho is the density of sphere. Calculated reality, the copper ball example. We have taken an example problem. Scenario, a copper ball of radius 2 mm falls through oil at 20 degrees centigrade. Terminal velocity 6.5 cm per second. Data provided G, value of density, rho is given, and density of oil, sigma is also given on this one. So, rearranging Stokes law for viscosity, it equal to 2a square rho minus sigma g by 9 Vt. So, we put the formula, we get the value of it as 9.9 10 to the minus 1 kg per meter per second. The elastic skin of liquids, phenomena of surface tension, minimum surface area, droplets from spheres to minimize energy. Elastic membrane, the surface supports weight like a stretched skin. Capillary action, liquid rising against gravity due to tension. Liquids possess a free surface with additional energy. They behave as if covered by stretched elastic membrane, constantly seeking to contract. The molecular engine, surface energy. Interior molecules attracted equally in all directions. Here you see these molecules attracted by all molecules, so the net force is 0. Surface molecules, unbalanced attraction pulls them inward. This creates potential energy. Conclusion, liquids minimize surface area to reduce the number of high energy molecules on the outside. Measuring the stretch, or you can find here the surface tension by this example, by this one. Work done equal force into displacement. Increase in area 2 into length into distance 2 dl. Factors 2 accounts for the two surfaces of the film, and surface tension work by increase in area. So we are getting S equal to F by 2L. The force per unit length acting perpendicular to the line, that is the surface tension in a film. Of course, it is a case of film actually. Weighting versus non-weighting, the angle of contact. Here you see this is non-wetting water on lotus leaf. Here theta is greater than 90 degree. Here what we find that the angle of cohesion, force of cohesion is greater than the force of adhesion. Right? Cohesion means molecules having the similar molecules, attraction with the similar molecules, that is mercury and mercury, right? And here you will find adhesion, the attraction between mercury and glass plate maybe. So this is less, so the surface area will be less, and the theta is 90 degree. So here it will not wet the object. It is non-wetting behavior. Wetting behavior, water on clean plastic. Here theta is less than 90 degree, acute angle. So here you can find that the force of adhesion is the greater than force of cohesion. So in this case the attraction is to solid and is greater than internal attraction. The third one is equilibrium of three interfaces. Here you see the three interfaces, as you see here is this one is SL, solid liquid interface. This is solid liquid interface. This is not right, liquid air interface, and this one is solid air interface. This one is solid SSA, solid air interface. This is solid air interface, and this one is liquid air interface. Here in this case we find SL, this is cos theta, plus SSL equal to SSA. So the balance equation, the shape of the drop is the result of these three tensions resolving into equilibrium. So from here we find the value of cos theta, and in this case we have taken the example of a water drops on a clean plastic, right? So theta is less than 90 degree, or you can say it as acute angle. Next one is laboratory measurement and data. We can measure the surface tension by this experiment. Here we have taken a weight, and here you can see this is glass plate is attached to the liquid, and here by the formula this is F by 2L, F is mg, therefore we get the value of mg here. So SLA is equal to mg by 2L. By this you can measure the surface tension by this experiment. Surface tension of liquids at 20 degrees centigrade, liquid surface tension, ethanol 0.0227, water 0.0727, mercury 0.4355. Formula reference guide, viscosity F equal to eta AV by L, Stokes law drag F equal to 6 pi eta AV, terminal velocity Vd 2a square rho minus sigma g by 9 eta, surface tension S equal to F by 2L, equilibrium of contact SLA cos theta plus SL equal to SA. SI units, viscosity, positive PI or Pascal second, for surface tension Newton per meter. Order within the flow. Fluids may appear chaotic, but they are governed by precise internal architectures, from the laminar layers that dictate viscosity to the molecular bonds that create surface tension. Invisible forces define the shape and motion of the liquid world. Thank you everybody for watching this video.